We're going to try and find the intersection between this parabola and this line. Now, if you think about this particular parabola, it has a negative transformation factor. So this thing is going to open like this, somewhere on the grid. This line has a negative slope, so it will be tipped something like this. Now, if the line and the parabola are in exactly the right spot, then I am going to end up getting two places where this line will cross that parabola. If the line is in the right spot, it might just clip the parabola like that and generate only one solution. Or it's possible that the line is too high and it misses the parabola entirely, so you have no solutions. So I'm going to need some sort of tool that allows for either two solutions or one solution or no solution based on the numbers that are attached to an x squared and an x and a number without an x at all. And that's quadratic formula. That's what it's for. So we're going to start off here with the fact that the y value of this particular thing is going to equal the y value of that particular thing at a point of intersection. Okay, now if you think about it, just pick this particular point of intersection, for example. That's a coordinate, like 3, 5 or something. Both the parabola and the line have to be crossing through the dot 3, 5 in order for there to be a point of intersection there, which means their y value has to match. Their x value also has to match. That's a less convenient fact because the x's are all blended up in this and they're all blended up in that. So there's no easy way to hook x to x, but I can hook function to function like so. So I'm going to do that. So f of x, I have negative 2x squared plus 12x minus 10. And I've got negative 2x plus 10. Now I've got stuff all over the place, but I have numbers with x's attached and I have numbers without x's attached. So I could gather like terms to get those two things together. So this doesn't have any friends to join it. 12x was already there. Add 2x to both sides to get this over. This negative 10 was already here. Subtract another negative 10 to get this over on the other side. And there's nothing left on the right side at all now. This negative 2x squared can't be combined with anything. It's the only term that has an x squared. Oh, that's supposed to be plus 12x. There. 12x plus 2x is 14x's. Negative 10 subtract 10 is negative 20. And there's still nothing over there. So a number attached to an x squared, a number attached to an x, and a number with no x at all equaling 0 is the exact setup you need for quadratic formula. So considering that there might be 2 or 1 or no points of intersection, I'm just going to check that with my discriminant. So b squared, 14 squared would be 196. 4 times negative 2 would be 8. 8 times negative 20 would be negative 160. That's going to be 36. That's a positive number, so I'm going to end up with two solutions for this particular point of intersection. So I might as well proceed with my quadratic formula. X is negative b plus or minus b squared minus 4ac all in the square root x is negative 14 plus or minus square root of this thing, 196 minus 4 times negative 2, negative 20. I already did all this work and found out this was 36. 2 times negative 2 is negative 4. Square root of 36 is 6. So I've got case 1, negative 14 plus 6 over negative 4, and case 2, x is negative 14 subtract 6 over negative 4. Negative 14 plus 6 is negative 8. Negative 8 divided by negative 4 is 2. Negative 14 subtract 6 is negative 20. Negative 20 divided by negative 4 is 5. So I'm going to have 2 points of intersection. I'm going to clean these off so they're not in the way. One of them is at 2 comma something, and the other is at 5 comma something. So I need the y values because it asks for a point of intersection. Once you have an x, you can either fill it into this thing or you can fill it into that thing because they both generate the same y value at a point of intersection. I'm going to choose to use this one because it has fewer terms and there's less squaring. It's just simpler to use. So when x is 2, y would be negative 2 multiplied by 2 plus 10. Negative 4 plus 10 is 6. So 2, 6 should be my intersection point. When x is 5, y would be negative 2 times 5 plus 10. 2 times 5 is negative 10 plus 10 would be 0. So my other intersection point is at 5 comma 0. All right, I'm going to need to sketch these in order to confirm that. So I'm going to clear this off. So we'll have some work to do with that particular parabola. So first off, I can see the y-intercept is going to be at negative 10. My vertex is going to happen when x is negative b over 2a, which is negative 12 over 2 times negative 2, which is negative 12 over negative 4, which gives me 3. That's just the x value. I need the y value, so shove it back into the equation. F at 3 is negative 2, 3 squared plus 12 times 3 minus 10. Should be, that's 3 squared is 9 times 2 is 18. 3 times 2 is 36. Negative 18 and 36 is positive 18, minus 10 is 8. So I'm going to have a vertex at 3 on the x, 8 on the y. I'm going to do my x-intercepts now. So I'm going to use quadratic formula again, this time using just the equation of the parabola because I'm using it to find the x-intercepts of just the parabola. So x is negative b, that'd be negative 12, plus or minus b squared is 144. 4 times negative 2 times negative 10. Got negative 12 plus or minus 144 4 times 2 is 8. 8 times 10 is 80. And a negative times a negative times a negative gives you subtract. $144 subtract 80 is 64. Square root of 64 is 8. So case 1, x is negative 12 plus 8 over negative 4. Case 2, x is negative 12 subtract 8 over negative 4. Negative 12 plus 8 is negative 4. Negative 4 divided by negative 4 is 1. Negative 12 subtract 8 is negative 20. Negative 20 divided by negative 4 is 5. So I'm going to have x-intercepts at 1 and 5. Okay, so this mess out of the way and get my grid up here. I'll draw myself an axis. All right, so for the parabola, I have a y-intercept at negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Vertex at 3, 8. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. And I have x-intercepts at 1 and at 5. Okay. Now, if you can see the axis of symmetry happening here, this dot, the y-intercept, is going to have a mirror point over here, because the thing has to be symmetrical. And I allegedly have a point at 2, 6. So 1, 2, 1, 2, 3, 4, 5, 6. That will be here. And I have an intersection point here at 5, 0. Now that's encouraging because one of my x-intercepts happened to land on that intersection point. So I know that this intersection point is actually on the parabola. If I try and sketch this in, past that point because I know I'm supposed to. I mean, that looks like a parabola. Looks like that dot fit on there just fine. We'll try the line. This line has a y-intercept of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it drops 2 for every step you take in x. So take a step, drop 2. Take a step, drop 2. Oh, that's encouraging. Take a step, drop 2. Take a step, drop 2. Take a step, drop 2. There you go. So you were able to use quadratic formula to find the precise location of the intersection between that line and that parabola. I'm going to clear this off, and well, before we do, why would I do this? Why couldn't I have just sketched it? Well, if you can imagine, I probably spent a minute cooking this up so that I had an example that would work out at exact tidy values. That's not how applications go. Applications of this type of thing will be at horrible decimal places. They don't have clean x-intercepts. The parabola doesn't have a clean vertex. It's just a mess. So if you're trying to sketch it by graphing, you're never going to be precise enough to do so. But if you trust the algebra can do it even if the numbers are terrible. So I'm going to clear this off, and then we're going to try one that's terrible. Okay, so I have a parabola with the positive a value, so it's opening upwards. And I have a slope that's positive, so it's going to be slanted this way. So it's possible that it could intersect in two places. At a point of intersection, the function from this and the y value from that will return the same number, so I can just hook them together. So 1/2 x squared plus 3x minus 4 equals 1/4 x plus 3. I can't use quadratic formula unless everything is gathered up on the left side, so I'm going to pull this over and this over. So 1/2 x squared was already there. 3x was already there. Subtract 1/4 of x from this side. -4 was already there. And I'm going to subtract 3 to move this over, leaving nothing on the right-hand side. There are no like terms to gather for this one. It's the only x squared. So I have 1/2 x squared. 3 x's subtract 1/4 of an x. Now we could do this with fractions. That's, I think, going to make a mess. So if you can remember that 1 divided by 4 is 0.25, then 3 of these, subtract 0.25 of them, gives you 2.75 x's. And -4 subtract -3, it's -7. All right, so that's set up for quadratic formula. Looks like I'm going to have to put in 1/2 for an a value. Nobody wants to do that, so instead of 1/2, call it 0.5. All right, so quadratic formula, x is -b plus or minus b squared minus 4 times the a value times the c value. All divided by 2 times the a value. If I look at my discriminant there, a negative times a negative gives me a positive number. So I'll be adding to a positive number. So this is all going to be positive, which means I'm going to get 2 solutions, which I was sort of expecting. I'm going to need my calculator to tell me what 2.75 squared is. And I get 7.5625. And 4 times 1/2 would be 2. 2 times 7 would be 14. And a negative times a negative is a positive. 2 times 0.5 is 1. So I really don't need this whole division because division by 1 isn't going to change anything. So my x value is negative 2.75 plus or minus the square root of this plus this would be 21.5625. Okay, so I'm going to square root this. Be 4.644 if I round. So case 1 would be this number plus 4.644. Which gives me 1.894. Or case 2 would be negative 2.75 subtract 4.64. Negative 2.75 subtract 4.644 gives me negative 7.394. So one of my points of intersection is at 1.894 comma something, and my other is at negative 7.394 comma something. So where exactly on the y? Well, I need to fill my x values into one of these equations. I'm going to choose this one because it's less painful. So when x is 1.894, y is 1/4 of that, plus 3. So 1.894 times 1 divided by 4 gives me 0.474. So here. And when x is negative 7.394, y will be 1/4 of that, plus 3, because that's the equation I'm using. I put the 7.3, not 73. Negative 7.394 times 1 divided by 4 plus 3 gives me 1.152. Okay, so it's time to sketch this thing. So I'm going to need to figure out the vertex, the x-intercepts, and the y-intercept of my parabola so I can sketch it. So I'm going to clear this off so we have some space to do that. So I can see that the y-intercept happens at negative 4. Vertex will happen when x equals negative b over 2a. So that's negative 3 over 2 times 1/2. That's negative 3 over 1, which just gives me negative 3. I need the y value for that, so I'm going to have to put negative 3 back into my equation. Negative 3 squared would be 9. Half of 9 is 4.5. 3 times negative 3 is negative 9. Negative 4. 4.5 subtract 9 is negative 4.5, and negative 4.5 subtract 4 will give me negative 8.5. So I have a vertex at negative 3 on the x, negative 8.5 on the y. And my x-intercepts are going to happen when I use the quadratic formula on this. So it will be at negative b plus or minus b squared, 3 squared is 9, minus 4 times the a value times the c value, all over 2 times the a value. So 4 times 1/2 would be 2. 2 times 4 would be 8. A negative times a negative gives me a positive. 2 times 1/2 is 1. So I end up with x is negative 3 plus or minus the square root of 17, all divided by 1. And I'm not going to write that because it's not going to make a difference. We're going to have to square root 17. Root 17 is 4.123. It's a fun number. So case 1 would be negative 3 plus that. Gives me 1.123. 4. Case 2, this number subtract that would be negative 7.123. Just gonna check that. Indeed it is. Okay, so got x-intercepts at 1.123 and negative 7.123. So I can clear this off, get my grid down here and sketch it. There we go. Set up an axis. So y-intercept at negative 4, 1, 2, 3, 4. And the vertex at negative 3, negative 8.5, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8.5. X-intercept at 1.123, well that's a little more than 1. And at negative 7.123, 1, 2, 3, 5, 6, 7, it's a little bit past negative 7. And I'm supposed to have a point of intersection at negative 7.394, 1, 2, 3, 4, 5, 6, 7, and a bit. And at 1.152, that's up a little bit here, maybe there-ish. And I'm supposed to have another intersection point at 1.894, that's about here, and 0.474, which is about there-ish. My axis of symmetry, I can see my y-intercept will be reflected to there, so I'm able to sketch in this parabola. Like so. Okay, so this line is supposed to have a y-intercept at 3, 2, 3, that's here. And it's supposed to go up 1 over 4 for every step. So up 1 over 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4 and down. 1, 2, 3, 4 and down. Well, look at that right there. 1, 2, 3, 4 and down. Now you notice that this intersection point and that intersection point didn't land on top of each other. So there's an error here somewhere. And if you get an error like that, the first place I'm going to check is the y value of my point of intersection, because that's the easiest thing to calculate. So I should have my y being 1/4 of the x value plus 3 1 times 1.894 divided by 4 is wow, calculator, that's not good. 0.894 divided by 4 plus 3 equals 3.474. So that number is wrong there. It should be 3.474. So if I fix that, I go to 1.894 and up to 3.5. 1, 2, 3.5. There we go. That's where that line should cross the parabola. Okay, so hopefully the lesson here, well, one, apparently at 6:30 in the morning, I'm not capable of using a calculator. But number two, if you actually sketch these, it has to intersect there. So your algebra has to work out. So if your numbers aren't matching, the picture has given you a justification or a prompt, I suppose, to go back and check your numbers. And fortunately, in this circumstance, I had just made a goof getting my y values, and when I recalculated, I ended up with them exactly where they needed to be. So even though this was gross and none of the points were in clean places, I was still able to use algebra to get exactly where the line and the parabola come together.